Hey guys, I'm not feeling so good today, so I'm not going to be there this morning. So I'm going to give you a couple of examples on what we've covered earlier this week, which is our complex numbers. So if you remember, complex numbers are in the form a plus bi, and you can see them written as a plus bi. You might see them written as c plus di. You can see it written as h plus gi. It doesn't really matter what the letter is that's used, the placeholder. It's just that you have a couple of components. The first one is that you have the real component, and that's the real number. A and B are your real numbers for this one. C and D would be your real numbers for this one. H and G are real numbers. Now, those are both real numbers. However, the A, the C, and the H are considered your real components of the complex numbers. Complex numbers are combinations of real and imaginary numbers. So the imaginary component comes in with the I. So we have a real component and imaginary component. And when we plot these, if you get into vectors, we talked about vectors, those are your imaginary components. Okay. So I have a real number and an imaginary number. So again, we're of the form a plus bi. So when you get, why do we use imaginary numbers? Well, imaginary numbers came about because we had to find the solution to taking the square root of a negative number. So when you do imaginary numbers, we're using a representation for the square root of -1, and we're going to call that I, which stands for imaginary, very tricky. And that is going to help us write numbers that are negative square roots using letters, variables, I, etc. So we don't have to have that negative square root component in there. You know, mathematicians find ways to represent everything. There are some things that we can't tangibly represent, but we can theoretically represent, and that's what the square root of -1 is. So I have I equals the square root of -1. So, for example, if I have, I'll give you a couple of examples here. If I have the square root of -4, I can't do anything with that. If I put that in my calculator, I'm going to get an error because we cannot take square roots of a negative number as far as we've learned for the rest of our math background. But here we can use the I to simplify this a bit and indicate that we do have an imaginary component. So what we're going to do is we're going to break this apart, because you remember your product rule for square roots. I can take the radicand, which is under the square root sign, and I can break it apart and factor it. Well, doing this enables me to simplify this. Square root of 4 is actually 2. And then square root of -1 I can represent with an I. So my imaginary representation for the square root of -4 is 2i. So let's try another one. Let's say I want to do the square root of -16. Well, again, I can take that negative component and separate it using the product rule. So now I can focus on square root of 16, which happens to be 4, and square root of -1, which is I. And once again, I've written this as an imaginary term. So that enables me to eliminate that square root, that negative square root. You will have seen this before when you did the quadratic formula, which is the opposite of b plus the square root of b squared minus 4ac over 2a, which is what helped you find the solution to a quadratic equation. And some of you may have used I before to represent your non-real roots, your imaginary roots. So this is what the simple imaginary number looks like. Let's get into a more complex example. So I'm going to come up a little bit. So here is our second wave of examples. What if I have 3 plus the square root of -25? Well, that's another situation where I have a square root of a negative number. I can't just add these two together. The 3 is on the outside of the radical sign, and the -25 is on the inside. So those are not compatible with each other at face value the way they're written right now. But I do want to take that square root of negative 25, and I want to change that using the product rule. So I'm going to change that into square root of negative 1 times the square root of 25. What that gives me is the square root of 25 is 5, and the square root of negative 1 is I. So I can change that second part to 5i. So I actually, in fact, can write this as 3 plus 5i. Now you can see that this falls under the format of a complex number. With the 3 is your real component, the 5i is your imaginary component. So let's do one more example. So if I, for example, what if I did the square root, whoops, what if I moved my screen around? What if I did the square root of negative 81 plus 6? And I want to write that as a complex number. Well, remember, proper form is a plus bi. So I'm going to worry about the square root of negative 81 first. I'm going to take that. I'm going to use the product rule. I'm going to split that apart. And so the square root of 81, that's a perfect square, is 9. And then the square root of negative 1 is I. So if I come back over here, I'm going to have 9i plus 6. Well, the proper way to write a complex number is to have the imaginary term second. So I'm then going to just flip it around, and I have 6 plus 9i. So that is how you create a complex number from an imaginary number and a real number. Remember, you have a real component and you have an imaginary component. Now, just as a little extension, if you're not sure exactly what we would do with something like this, you're familiar with the Cartesian XY plane. You guys have worked with this before in algebra, where we have our Cartesian coordinates. We have the x-axis and we have the y-axis. Now, what do we do with imaginary numbers? Is there a purpose? Well, we can apply imaginary numbers. If you want to see a visualization of an imaginary number, think about a plane, a Cartesian plane, but instead of having an x and y axis, I have a real number axis and I have an imaginary axis. Real and imaginary. So let's, for example, look at this one here, 3 plus 5i. Well, what's my real component? 3. So I'm going to go over 3. 1, 2, 3. And then my imaginary component is 5, positive 5. So I'm going to go over 3 for the real, up 1, 2, 3, 4, 5 for the imaginary component. And what that actually does is it creates a vector. That vector is the vector 3 plus 5i on the complex plane. Let me give another example. What if I gave you the vector negative 2 plus 4i? Well, I've got my real component and my complex component. So I'm going to take the negative 2 on my real plane. So I'm going to go left 2. And then my imaginary component is 4, positive 4. So I'm going to go up 4, 1, 2, 3, 4. And that is my vector negative 2 plus 4i on the complex plane. And something that you'll see, and I'm going to do a separate video for operations, but just to kind of give you a preview, what if I wanted to add two complex numbers together? So let's take that 3 plus 5i, and let's add it to that negative 2 plus 4i. And I'll go more in depth on this in the next video on operations, but basically you treat this like terms. I can add the reals together. So what's 3 plus negative 2? That's 1. And I can add the imaginaries together. Treat these just like variables. 5i plus 4i is 9i. So now I've created another vector that is actually the sum of these two vectors. Now my plane, I'll go ahead and extend this out a little bit. 6, 7, 8, 9, just for funsies. So I'm going to go over 1 and up 9. So my new vector is going to be right here. That's 1 plus 9i. Now, how do we get that? Well, we're not going to get too in-depth with vectors, but I want you to imagine when you add two vectors together, you're basically going to take the tail of one and put it on the head of the other. So imagine this purple vector. If I just shifted it over and stuck it on the edge or the head of that one, do you see how it ends up where our sum is? So that's how vectors work with imaginary numbers, complex numbers. So again, this is called the complex plane because you have a real component, which is your horizontal axis, the way we see it in our perspective, and you have an imaginary component, which is the vertical axis. And I'll talk about operations in the next video.